Hello and welcome. This is an open process problem where a tank initially contains oxygen. The conditions are given, 200 kPa, 20 degrees Celsius, and the volume of the tank is also supplied. And then the valve is open and oxygen enters from a supply line at 20 MPa, 15 degrees Celsius, and fills up the tank until the pressure equilibrates inside to 20 MPa. We are asked to find the final mass and the final temperature and the exergy destroyed during this process. I have already partially set up the problem to discuss how we can solve complicated problem using test. So state 1 is the initial state, the beginning state of the tank. Of course, oxygen was selected here. The pressure is given. Initially, it contains oxygen at 200 kPa, and the temperature is supplied, volume is supplied. So state 1 is no problem. How about state 2, the final state? What is given to us are the final pressure, and of course the volume doesn't change. We don't know any further information. Let's go to state 3, the state of the inlet state. Again, here sufficient information is given to us, pressure and temperature. Of course, we don't know M2, so therefore we don't know what is M3 is. So with this information, if we set up the process, beginning state is state 1. This is my beginning state, this is my final state selected, and there's an inlet state. Once we select state 3, oxygen appears. So everything is looking fine here. Usually, if there is only one unknown, then if I put Q equals 0, the energy equation can be solved because there is no Q, there is no W, and there is, in this case, there is only inlet, so there is no exit at all. But the problem here is that we don't know state 2. We don't have sufficient information on state 2. So let's go check it out first. Suppose we set Q equals 0 and do a calculate. The equations will be unable to go and substitute. You'll notice state 3 is not populated. If there was sufficient information, suppose the mass was known, then E would have been substituted here. So how do you solve such a problem when it seems like there is the test doesn't iterate among mass energy equation enough to solve that problem? Well, you can use a simple trick. So leave your Q unknown and calculate without knowing Q. Go back to the state and let's guess the temperature for state 2. We know state 1 temperature is 20 degrees Celsius. Let's do this in Kelvin. It will be nicer, which is 293 Kelvin. So let's say we say in state 2 temperature is, we know it will go up. Let's say it's, 500 Kelvin. Once we calculate this, and we can do a super calculate if you. Okay, now we do a super calculate, and that will find, or you could come here and do a calculate on the process panel. Now that state 1 and 2 and 3 are known, the heat transfer is calculated, which means that to achieve 500 Kelvin at the second state, at the final state, we need to heat up the cylinder with this amount of heat. So obviously we have to re-guess the temperature because there is no heating. The cylinder is insulated. So our guess must have been a little bit too high. So what we do now is that we go back. Remember, this is 48. So let's go and improve our guess for state 2, the final state. Oops, velocity should be 0. Instead of 500 Kelvin, let's say it's okay. Let's guess, 350 Kelvin. How about that? Because we started with 300 Kelvin, calculate this state, and we could come here. It automatically calculates, or when you come here, calculation is done. Note it's negative 40. So the answer might be somewhere in between. So this is the way we go back, and I have already done the problem, so I know what creates a close enough answer. 404 Kelvin. If you come now to the process panel, well, you can do a calculate, but you can see it's pretty close to 0. You can refine it by guessing T2 again and again, but this is how it works. So the entropy generation is now calculated and boundary temperature is known. So the exergy destruction can be done here if I declare a variable I equals Sgen1 times 298, or I could write TB1 for that matter, boundary temperature at 1. T boundary at 1, this is the variable name. And if I do a calculate, it should calculate the entropy exergy destruction during this process. So this is an example how you set up the problem so that you can guess one of the variable and make sure the condition of the problem is satisfied. In this case, the tank is adiabatic and there is no heat transfer.